area of circles. I did make us a quick formula cheat sheet if you want to copy it down. Let me load it up. Where are we at? Oops, and here. Okay, so here's, the main formulas we'll be exploring and using today. And in fact, we'll mostly be using, let me glance at how I look really quickly. Yeah, that all looks reasonable. We'll mostly be using the area formula today. Area is already like 6th grade, late 6th grade standard, and circumference is even before that. So, but let's look at this. So, what do I got here? Area and circumferences of circles. There's a few vocabulary words I want us to practice, and the first one is actually, you'll see it a lot on here. It's not the one you think it is. It's radius. Let me get a different color. Okay, so radius. The radius, when we hear it with reference almost always to circles, as far as I know, the radius is the distance from the center of the circle to any edge of the circle. So this radius, right? This is a radius. Okay, that's the radius of that circle. The radius of this circle is, again, it could be any direction. This is the radius. And it doesn't matter what direction it is because it's all the same, right? Like this red line, because it goes from the center to the line, is the same length as this orange line. Okay, there's no, that's just how circles work, is that like their boundaries are always equal distant from the center. Okay, so each one of these lines is the radius, right? Good. Okay. And let's see, there's some other vocab that we're gonna look at that I'll go over. Let's start with just our initial description, which is pi. So I guess we gotta practice pi today. Pi, also written like this, although that's not, the font I use to type that doesn't really capture. Usually when humans write it, we write pi more like this, right? You guys have seen that maybe. Pi is a symbol, and it stands for a ratio. It stands for a specific number. And the number that we teach you when you are in 7th grade, although you'll see there's more to it, is we ask you to memorize 3.14. Anytime you see the symbol of pi, if you plug in 3.14 for most middle school level work, that's kind of all we're looking for. And if you don't want to deal with it as a decimal, a fraction that's very, very close to 3.14 is 22 over 7. So, like this, that's 22 divided by 7. And those are the two things that as middle schoolers, I think is worth memorizing, is what I'd say. Because, let me check the chat. I think I saw something. Oh, good. It's just people responding. Excellent. Good interaction. So those are the two ways that you can kind of like estimate very close to what pi is. But pi itself, I'll tell you, isn't exactly 3.14. You might know this, but pi is actually it's what we call an irrational number, because it's actually a number that doesn't end. If I was going to write out pi, it would be like, it would actually be like 3.14159 ... 17 51 41 1 billion, blah, blah, blah. It just keeps going on forever. It's like infinity digits. And but again, like usually 3.14 is close enough for our purposes. Now, what is pi is kind of a good question, and pi is a number that's mathematicians and people have noticed is it's a ratio. Okay, like why did we even invent pi in the first place? Like, why does that exist? Because when people were working with circles and doing math, we noticed that the diameter of a circle, okay, and a diameter of a circle is just, it's two of the radiuses, right? You see that? Like one radius is here to here. So if I just add one more radius, it's like there. So two radiuses is a diameter. The diameter of a circle is like a straight line through the center of the circle. And we noticed that the circumference of a circle, circumference being this area around it. So I'm going to draw a really sloppy circumference because I'm freehanding it. But like, oh, actually, it was on straight edge mode. So if I take the circumference of the circle, let me see if I can do this without. Okay, pretend that's a perfect circle. Okay, and if I stretched out, like let's pretend I was unfurling this circle. Like if I could, I can't really do it in this art program, but if I had like a piece of string in real life, that's how I do it. I'd like wrap the string around and then open up the string. And then if I laid it out, so do I have room here? I'll just do it in the air. Okay, so if I laid that out, so pretend like this green is me like grabbing this thing up here and ripping it open. Okay, and right now I just kind of guessed. Okay, I'm not, this isn't an exact line. But if you like open up the circumference circle and laid it straight out, what we noticed is that when you grab the diameter, okay, so this is the diameter, okay, and it's got two parts because I was marking it as radiuses. We noticed that when you lined up the diameter next to the circumference of any circle, that you always notice something. So in fact, look, so you know how I was eyeballing this green line? I can actually show you almost perfect how long that green line should have been, and that is about, let me put the diameter back. It is about this long. So I can see I made my green too short, actually. Let's go back to the green. The green should have been, oops, that's on selection mode. Okay, my diameter should have been actually all the way. So this is, you know, all right, let me do down here. 1, 2, 3.14. So that's like, you know, 10%, slightly more than 10%, 14%. I'm thinking like there is probably close. Okay, close enough. It doesn't really matter. I'm at, like, you just got to see how. So this one is my practice one. Nothing's wrong. Okay. But let me move you guys so you can see. I'm not sure. Let me glance at your perspective really quickly. Sorry. Okay. So what you should be seeing here is like if I had unfurled this green line, this is how long it would be, this green line here. And that's the circumference, right? That keyword there, I keep saying circumference. Circumference of the circle, it's like the measurement of the circle. Okay, the measurement of the distance on the outside of the circle. And what we notice is that for any circle at all, so, oh, I can't easily draw a circle actually. Maybe, I mean like, this kind of would let me easily draw a circle. I wanted to get like a real, let's use 3 dimensions for this. Use wire, let's use purple. So first let's get a circle. Oh, first let's get a circle. An almost perfectly straight circle. Okay, so for this circle here, see this perfectly round pink circle? Again, if I unwound this pink part, how long would it be? Well, since again, I'm in a game that doesn't let me like physically move it, what I could show you though, again, is I get the diameter, which we'll use, what color haven't I used? Yeah, yellow, I guess. Green? No, we use green. I mean, we can just use gray. Okay, so look, oh, here's this gray diameter, right? And again, if I just take this gray diameter and I laid it out 3.14 times, because that's what pi is. So, you know, 1, 2, 3, and then a little bit more, because that's where the 0.14 is. So I'll just draw it in by hand because I can't, you know, easily paste that like 0.14, like that much. Okay, that must be the length, like, of this pink ring. If I could, and we can kind of see that, right? Like, I guess there's no easy way to to like to untwist it, like I said. But basically, yeah, that's how long, that's how big the circumference of a circle is. It's all about that ratio of 3 and a little bit, 3.14. That's the ratio between this diameter and the circumference. And that's where pi comes from. That's why That's why we learn it. And we use pi to like, it's going to be a nice shortcut to mathematically calculate certain things with circles. And it's going to be useful for the circumference, as well as I'll show you today, which is, the real focus of today's lesson,